Welcome. Today we're doing a deep dive into something truly catastrophic, Earth's most severe extinction event, the Great Dying.
That's right. We're going to look at the sources, piece together what happened, why it happened, and maybe see what lessons it holds.
Lessons indeed. So let's start with the basics. Just how bad was it? What kind of event are we actually talking about here?
We're talking about roughly 251.9 million years ago, right at the boundary between the Permian and Triassic periods.
Okay.
And the scale. It's honestly hard to grasp. It was the worst extinction event we know of.
Worse than the dinosaurs.
Oh, much worse. We lost something like 81% of all marine species. Gone.
81%.
Wow. And on land, around 70% of vertebrate species. Even insects took a massive, massive hit, the biggest insect extinction known.
It's almost unimaginable, a near total wipeout. What on earth could cause something like that?
Well, the scientific consensus is actually pretty strong on this one. It points overwhelmingly to one main trigger. These enormous volcanic eruptions flood basalts in what's now Siberia, the Siberian traps.
Not just a single volcano, then.
No. Think lava fields covering huge areas, erupting for a very long time, and releasing just colossal amounts of gases.
Okay, like what kind of gases?
Primarily sulfur dioxide and, crucially, carbon dioxide. CO2 levels in the atmosphere just skyrocket.
What are we talking?
The sources suggest it went from maybe 400 parts per million ppm up to around 2,500 ppm.
2,500, that's immense.
Exactly. And that had huge knock-on effects. Global temperatures jumped by about 8 degrees Celsius or 14 Fahrenheit.
Okay, so extreme global warming.
Yes. And the oceans suffered terribly, too. All that CO2 getting absorbed made them highly acidic.
Right, ocean acidification. I've heard about that.
The pH dropped significantly, maybe up to 0.7 units, and large parts of the ocean became anoxic, or euxinic, basically, starved of oxygen and full of toxic sulfur compounds.
So the air, the temperature, the water, everything turned hostile.
Pretty much. The planet was, in a sense, suffocating itself.
So, with the environment becoming so toxic, what did that mean for the life that did manage to survive? Was it just random luck?
Not entirely random, no. It was selective. Organisms with calcium carbonate skeletons, like corals, certain shellfish, they were hit extremely hard by the ocean acidification.
Makes sense. Their shells literally couldn't form or would dissolve.
Precisely. And on land, large herbivores also suffered disproportionately. Maybe changes in vegetation played a role there, too.
And the overall ecosystem.
Devastated. Forests largely disappeared. And we see this interesting thing called the Lilliput effect in the survivors.
Lilliput effect, like Gulliver's Travels.
Kind of, yeah. Surviving species often became much smaller in size for generations, probably an adaptation to scarce resources in a really harsh world.
Fascinating. And how long did it take for things to get back to normal?
That's maybe the most sobering part. Recovery was incredibly slow. We're talking maybe 10 million years, maybe even up to 30 or 50 million years for full ecological recovery.
50 million years?
Yeah. There's even a coal gap in the early Triassic geological record, a period with almost no coal deposits, showing how long it took for forests and peat swamps to really reestablish themselves.
That timescale is just staggering. Which I guess brings us to the present.
Yeah.
How does this ancient apocalypse relate to us now?
The parallels are, well, they're pretty stark. We're again seeing rapid release of huge amounts of carbon dioxide.
This time from us, though. Human activity.
Exactly. And we're already observing the consequences: warming, ocean acidification, oxygen minimum zones expanding.
So, similar mechanisms at play.
Very similar. There's a quote from geologist Lee Kump that really hits home. He says, "The Great Dying is a stark reminder of what happens with rapid CO2 emissions."
And he points out
That today we're driving similar processes, but potentially even faster. The rock record shows that once you hit certain tipping points, the negative effects on ecosystems can last for millions of years.
millions of years. That really puts things in perspective.
It does. It shows how profoundly and for how long these events can scar the planet.
So the final thought for you listening, this ancient catastrophe isn't just a story from the deep past. It's a case study, maybe a warning. It shows the immense power of Earth's systems, but also the incredibly long shadow cast when those systems are pushed too far too fast. What kind of multi-million-year trajectories might we be setting in motion right now?